Hello guys, welcome back to Tronics Energy. So last time we started on our series of making the 8-bit logic unit, and we said the 8-bit logic unit will only be doing some logic operations. So these are the ICs. These ICs on top of here are the logic, the logic operations that this multiplexer will be choosing. So the whole circuit will be called 8-bit logic unit. So last time we started off with the AND gate. We started off with the AND gate, and it was combining A and B. And that output, we took it to our D0 right here. So the data lines of the multiplexer we are using, these are 74153 multiplexer, has two 4x1 multiplexers. There's a one on top and there's another on the bottom. So we are using this one on the bottom. We are using this one on the top. Then we are going to combine it with this bottom one to make the 8-bit ALU. So these are the data lines that we have on our top multiplexer. It has pin number 10 as D0, pin number 11 D1, 12 D2, 13 D3. So all of them have some codes that they use for us to retrieve information from them. So the D0 has 00, the D1 will be 01, the D2 will be 10, and the D3 will be 11. So in our previous episode, D0 we kept AND gate, and for us to get that code, or for us to get that information of A and B, we had to put 00 on our select. This is our select switch. We had to put 00 in our select. Once we put 00, it's going to show us the AND operation of A and B. What's the output of A and B? So for today we were to do another logic, and today we are doing an OR. This is an OR IC. So 7432 has four 2 input 1 output OR gates. We are using the first ones, pin number 1 and pin number 2 as the inputs, pin number 3 as the output. So that pin number 3, I've connected it to D1, pin number 11 of the multiplexer 74153. And for us to get the information of A or B, we'll have to put 01 in our select. So this is the code that's going to be representing OR. 01 will be representing OR in our IC. So once we put 01, the output will be showing us the OR operation of A or B. So looking at our block representation of the multiplexer, A, we said that it's going to be AND gate. B will be OR gate. Of A or B. Will be checking A or B. So that's the other input. So we'll be remaining with the other two inputs. Then after we're finished with those two inputs, we are going to merge this multiplexer with the other one to make an 8-bit ALU. So go start off. We can now power our circuit and check what's going to happen. And it is on. So it's on, and nothing is on because the input sections are all 0. So the input section of this first one, A is 0, B is 0. Yes. So because the select is 0 0, meaning that we have selected AND, the AND operation of A and B is giving us a 0 output. Why? Because both inputs are 0. If you can remember AND operation, both inputs have to be on in order to give an output. So because A and B are all 0, it's going to give you 0 output. So if I'll turn them on, all of them, yes, try to make it, yes, like that. If I turn them, all of them on, then the output is on. Why? Because A and B are all 1. For an AND gate to give one output, both inputs have to be on. And the output enters D0, and the code for D0, for the code for the AND gate is 00. So because the select is 00, it has selected AND operation, and AND operation has given a 1 output. That's why that 1 output is being represented by the output LED. So today we have a D1, and D1, for us to source D1, we have to put this code 01 in our select. So we put this on. Okay, we put that on, turn this off. Yes, 01. Yes, 01. Yeah, and 01, the output is still on. Why? Because OR operation, for an OR gate to give a one output, either A or B should be 1. So because of all of them are 1, definitely it's going to give a 1 output. If I was to be turning one input off, it's going to turn off. It's going to remain on because one of the inputs are on. Like for example, let me turn A off. It's still on. Why? Because one of the inputs is on. Let's turn A back on. Let's turn B off. The output is still on. Why? Because one of the inputs is on. If I was to be turning all of them off, if I turn all of them off, then the output should be off because A or B are all 0, so it's going to give a 0 output. So if I turn this off, then it's 0. We have selected OR, and OR operation is giving 0 because A or B is giving 0, so that's why the output is going to be 0. And to differentiate this from an AND gate, we are going to check. If I'll turn this one of the input on, it's going to turn on. If I turn it back, if I give it the code for AND gate, it's going to turn off because AND gate operation, both inputs have to be on. So let me turn this off. If I turn it, then the LED is off because 00 is the code for AND gate, and when this IC now is enabled, and when this IC looks at A and B, it checks that A is 0, so it's going to give you a 0 output. That's why the LED is 0. So that's basically the operation. Now we have combined the AND gate and the OR gate. Now they are both in the multiplexer, and the multiplexer has 2 more. This top one has 2 more inputs that we are going to put NAND and NOR operation. And from there, we'll move on to combining this multiplexer with the other multiplexer on the bottom right here. And we are going to make an 8 by 1 logic unit. So we have started, we are continuing on well, and yeah, I really hope that you understand, and we are moving on well. So next time, this is a NOT gate. We are going to invert those outputs of the AND gate to make NAND gate, and those output of OR gate to make NOR gate. Then we are going to put them in the IC, and we are going to give them codes. They are going to have different codes. So for now, 00 is the code for AND gate, and 01 is the code for OR gate. Now we are going to check this last code, 10 and 11. Yes. So thank you very much guys for watching. Please subscribe to Tronics Energy, where we do fun stuff all day, all time. Hope to see you next time. Goodbye.